Let's get started for a few minutes by talking about the scientific method, which is a really important concept in biology. And you might think the scientific method is something fairly new, but it turns out that it's something humans really instinctively do to try to understand the world around them. And one of my very favorite little cartoon clips is a Calvin and Hobbes, where Calvin and Hobbes are looking at the toaster and a piece of bread, and Calvin puts the bread in the toaster and shows Hobbes how the toast pops back up in a few minutes. And, Hobbes says, wow, where does the bread go? And this always makes me think of ancient humans and, what they must have thought of the sun going down and coming up the next day, and where did it go and would it come up? And all of the superstitions that people employed and prayers they would offer and explanations they would come up with to try to explain this phenomenon that they didn't understand. But humans actually have some built-in capability of understanding the world around them. And maybe the easiest way to understand this is just to think about a baby. Babies are natural scientists. In fact, a few years ago, a person put out a book called The Scientist in the Crib, and just explained the different ways that babies really employ the scientific method. But here's a great example. So here's a baby. This baby's making an observation, and they see this thing on the ground, right? And they're going to pick it up. And the second step of the scientific method is to form a hypothesis. So the baby looks at this item, and so the baby's going to make an assumption and then test it. So the assumption, the hypothesis is this is food. And if you've ever been around babies, that's always their initial hypothesis. Because the first thing they do when they pick something up is they perform an experiment. They put it in their mouth and taste it. And so here you can see the baby tasting the item, and then step 4 is analyzing the data. The baby makes kind of a funny face. It must not have tasted that good, and then the baby starts to cry. And in this particular instance, we refer to this as peer review. This is where you take your experiment and you write it up and publish it, and you tell all of the other people in your field exactly what you discovered. And then good scientists always ask others to reproduce their results. In fact, science isn't considered credible unless people can reproduce the results. So these are the 6 steps to the scientific method. And of course, you can apply observations, hypotheses, experiments, data analysis, and the idea that we report our findings and that our findings are reproducible. Other people get the same results. This is the cornerstone of understanding science. So why am I starting with this? Well, when we think about early microbiology, they were asking some really big questions. They observed that life was on Earth, but they didn't know where it came from. They observed that diseases ravaged humans and animals and plants, but they didn't understand what caused them. They had some crazy ideas about what caused diseases because, when we can't explain something, we usually invent explanations. So, for example, people talked about miasma, bad air. Maybe breathing bad air caused disease. People certainly thought that diseases might be punishment, that people got sick because they had behaved badly or they didn't offer prayer to the right God. There was a sort of a karma, right? That if you do something bad will happen to you. So there was lots of explanations like that. And they also didn't really understand how diseases were transmitted because we weren't able to get a handle on that until we understood what caused diseases in the first place. There were 2 really major questions that scientists were asking in early microbiology. And these were, where does life come from? There were 2 major hypotheses that people had. And these hypotheses included something called spontaneous generation. This is the idea that life just arises from non-life, that something inanimate can result in life occurring. And the other explanation was that life can only come from pre-existing life. So this is referred to as biogenesis. And these were 2 competing hypotheses that scientists in exploring early microbiology were debating with each other and doing experiments and testing. And so our next video is going to cover some of these early microbiology experiments.